So next problem is integral root a plus x by a minus x dx. So by seeing the question itself, we can understand that we cannot move forward with this a and x. So something should be there to replace this variables. So in place of x, I am just replacing x as a cos 2 theta. Okay, keep that in mind. Most of the problems will do the same procedure. Okay, if we take the dx of this one, it will be d by, if we take the differentiation of a, it is a itself. Now what is differentiation of cos 2 theta? That is minus sine 2 theta. Now differentiating 2 theta, it will be into minus a into sine 2 theta into 2 d theta. Okay, so we can rewrite this thing as integral root a plus, in place of x we'll write this one. So a cos 2 theta divided by a minus a cos 2 theta. In place of dx we can write this one, right? There is a 2 and minus a is there, so let's take it outside to a. Okay, sorry, a we cannot take right now because it has to be taken as a common term. So take 2 outside, write rest of them. So a sine 2 theta d theta. Okay, now take a outside. From all of them we can take a outside, right? So we are taking a outside. Minus 2 integral to a. So if we take all these a's, what will be remaining? 1, right? 1 plus cos 2 theta divided by 1 minus cos 2 theta sine 2 theta d theta. Okay, so now cos 2 theta is equal to 2 cos square theta minus 1. Okay, so if we replace the cos 2 theta part with this one, okay, what we are going to get? Let's see that. Okay, so I'm just replacing here 2 cos square theta minus 1. 2 cos square theta minus 1. Okay, yes, so this 1 minus 1 both will get cancelled. Here also 1 minus 1 will get cancelled. So the remaining is, oh sorry, don't miss this root. Root is there. Okay, so the remaining part is minus 2a integral root 2 cos square theta, yes, divided by so here we have, I'm just writing it again, minus 2a integral, we had 1 plus cos 2 theta divided by 1 minus cos 2 theta, right? So we have two formulas for cos 2 theta, that is cos 2 theta equal to 2 cos square theta minus 1, as well as we have 1 minus 2 sin square theta. So both are there. Okay, so in place of 1 cos 2 theta I am substituting this one, for the other I am substituting this one. Okay, otherwise this problem will stuck. Okay, so just think and write accordingly. So if I replace this one, so this will be 2 cos square theta minus 1. This is 1 minus 2 sin square theta. So these two will get cancelled, these two will get cancelled. We have a root over here. So the remaining is going to be, this is like this, sin square theta minus 1. Okay, yes. So the remaining is going to be minus 2 root integral minus 2a integral 2 cos square theta divided by 2 sin square theta, and what is left, we had sin 2 theta d theta, right? Yes. If we take the root of this part, this is going to be, this root will get cancelled, the square also will gone, this 2 also can be cut, right? So what is cos theta by sin theta? We can write it as such, let it be there. Okay, and in place of cos 2 theta, I can write it as 2 sin theta cos theta, right? So this sign and this sign will get cancelled, and we can take this 2 also outside. Okay, so this will be minus 4a integral, the remaining was cos square theta d theta. Okay, now in place of this cos square theta, if we take, we need to integrate this one, right? We have to integrate this cos square theta. Okay, so we know that cos 2 theta is equal to 2 cos square theta minus 1, right? Okay, so if I take a 2 from here, so this is almost similar to this one. Now this minus 1 I am taking along with cos 2 theta. See, plus 1. So 2 cos square theta will be cos 2 theta plus 1. So yes, I am rewriting this term as cos 2 theta plus 1. Now integrate this one. So we'll get minus 2a integral 1 plus cos 2 theta d theta will be equal to minus 2a into integral 1 is theta plus integral cos sine 2 theta. Now integral 2 theta, that is divided by 2 plus c. Okay, so this will be our final answer. So let's see another problem which is very important and application level, and usually these are some model problems which may come for the entrance test as well. So let's begin here. So first of all, see, if we need to just reduce this term, okay, so our inside root we have 3t and 2t square, right? So suppose I am taking 1 by root 2 outside from this. Okay, what will be the remaining? If we will be getting it as 3 by 2 t minus t square, right? And t square, if we write this thing in an order, so first t square will come, right? So for that we need to take minus outside, right? So t square minus 3 by 2 t will come. Clear? Okay. Now why I have written like this? Because we are going to write this term like in the formula a plus b the whole square. Okay, so this is going to be t square minus, we just have 3 by 2 into t. Okay, so the square term, we need 3 by 2 the whole square, right? We need that. So since we don't have it, there is a root, don't miss it. We don't have that. So what we will do is, we'll just add and subtract 3 by 4 the whole square. Okay. So it will be 1 by root 2 integral dt divided by minus, yes, there is a square, minus t square minus 2 into 1 by 2 into 3 by 2t plus 3 by 4 the whole square minus 3 by 4 whole square. Clear? So now we got it in the form of a plus b the whole square, right? Yes. So we can write it as 1 by root 2 integral dt divided by root of minus t minus 3 by 2 the whole square minus 3 by 4 the whole square. Clear? Yes. And if we multiply this negative inside this bracket, okay, so what it will be? Just the order will change, all other will be remains the same. So this will be root 3 by 4 the whole square minus t minus 3 by 4 the whole square. There is a dt, right? Yes. Sorry, dt is already there. Now if you see, this is like 1 by root 1 minus x square, right? If I am taking this as a constant, this is 1, this is x square, okay, 1 square and 1 both are same, right? So if you think 1 by root 1 minus x square, which is the formula of sine inverse of x, right? Am I right? Yes. Okay. So I can replace the whole term as 1 by root 2 sine inverse of, what is our x? That is t minus 3 by 4 plus c. Okay, so this will be our final answer.